Hi and welcome back to Gaffy's Grinds. This is video 13 in our series on cert organic chemistry. Can be improved. Now, one of the reasons why petrol is such a useful fuel, well, first of all, we use it for transportation in small vehicles like cars, mopeds, motorbikes, etc. And the reason why it's such a useful fuel is because it is a liquid at room temperature. So it's liquid at room temperature. Why is this useful? Liquid petrol is a liquid at room temperature. Why is this a positive? Well, it makes it really easy to store. It can be stored in tanks. That's tanks at a fuel station, but also tanks in a car. So petrol is easy to store because it is a liquid. So for example, this is a really crappy diagram of a car. You'll have to forgive me. But in a car, the petrol tank is usually a modern petrol tank is a plastic tank and it's stored towards the rear of the car. You obviously can't see it from inside the car. It's usually underneath the back seats or somewhere in around there. It's easy to store in fuel tanks. That's one of the things that makes it a really useful fuel tanks. So that's the first positive of petrol, is that it's a liquid at room temperature. Another positive is that it's really easy to ignite so long as your octane number is high. So octane number we've learned about already, and petrol is easy to ignite. It's easy to ignite and it releases a hell of a lot of energy. So it releases a lot of energy, and this is reliable energy. Every time we burn petrol, it releases energy, not just sometimes, absolutely every time. So you can rely on it. It releases a lot of energy. These red arrows now are going to demonstrate the amount of energy being released. So I'm going to draw a lot of red lines to show that there is a lot of energy released when you burn petrol. Okay, so these are the positives of petrol. One of the major negatives to do with petrol, okay, and why we are constantly looking for an alternative is that they produce carbon dioxide. It produces carbon dioxide when it's burned. So just like all other crude oil-based products, if you burn them, they produce CO2, carbon dioxide. Why is this a problem? Well, producing carbon dioxide, anything that which produces carbon dioxide is what we call a greenhouse gas. And you will be familiar, I hope, with a greenhouse gas as a gas which traps heat in Earth's atmosphere. So when we increase the concentration of the volume of CO2 in the atmosphere, we trap more heat, which causes this overall effect of warming up the layer that's inside our atmosphere. Okay, and the problem with this is it leads to what we call climate change, which are changes in, like, big overall changes in our major weather patterns. It's not just what the weather's like outside today, it's big overall changes in the extremes that we have of weather, like the amount of storms we have. Some types of storms like tornadoes or hurricanes, in some parts of the world, they might used to have been a 1 in a 50-year event. So you get one major hurricane every 50 years. Because of climate change, some of those numbers are down to 1 every 10 years or less. So we're talking about major climate issues. Also things like forest fires, uncontrolled forest fires in countries like Australia and in parts of America, like California, where you get these uncontrolled fires that humans can't stay ahead of them. And it's to do with how dry the land is, how hot the summers have been. Major droughts is another issue. So if your climate changes, those are the major impacts. So obviously that's an undesirable thing to happen. So what humans are trying to do is trying to come up with ways of avoiding this. So they're looking for alternative fuels. One possible solution that has been suggested is the use of hydrogen as a fuel. Hydrogen. Now, the reason why hydrogen would be desirable, first of all, I'm going to start with why would you want to use hydrogen? The reason why it would be desirable is it does not produce CO2 when combusted. No CO2 emitted. So straight away, you guys should be able to see why this would be desirable. If we go from burning loads of petrol in every vehicle on the road, every small vehicle on the road, if we could turn that to a state where we're using hydrogen instead and not producing CO2, then that would be a massive positive. Just like, before I give you another factor affecting the production of hydrogen, I suppose, well, why does it not produce CO2? Well, if we were to look at hydrogen gas, the symbol equation for hydrogen gas is H2. Now, when we combust any fuel, we mix it with oxygen. So combustion always mixes your fuel, which is hydrogen in this case, with oxygen. And what we get is just water as a product. So there you can see plus water. Now, petrol obviously has specific molecules, but it's got more than one. It's got carbons between around carbon 5 to carbon 10. So 5 carbons in length up to 10 carbons in length, hydrocarbons in petrol. So because it's not just a single type of hydrocarbon, I'm just going to put the word petrol there instead of a specific molecule in our reactants. But we're always producing these two products, CO2 plus water. That's unavoidable when we burn a carbon-based fuel. Hydrogen is not a carbon-based fuel, which means that we don't produce carbon dioxide. Now I'm going to have to remove this again to make more space for myself. So just so you know the difference here, no CO2 emitted for hydrogen, CO2 is emitted for a fossil fuel. So this is one of the big advantages. It is also very easy to ignite. So that's another tick in the positive column. It's actually even easier to ignite than hydrogen, than petrol. It's even more flammable, and the energy can be released. Energy can be released to move a car. To move a car. That is another tick in the positive column. Okay, so far we're going to sum up the pros and cons for each one. We're not just finished talking about them yet. We're just going to stop and take stock of what we have. Right, petrol is positive. It's got some positives. Here it's got a major positive that it's really easy to store. This is a positive, so I'm putting this here because petrol is a liquid at room temperature. It's easy to store. This is a positive. Petrol is easier to ignite and releases a lot of energy. It is reliable. Every time we burn it, it produces energy or releases energy. This is really advantageous. Hydrogen's advantages are it is also easy to ignite and the energy can be used to power cars in the same way as it can in a fossil fuel. So I'm using red lines again, red arrows to show the energy that's been given off. And I'm actually going to draw even more arrows for the hydrogen because potentially even more energy can be released. Hydrogen is used as rocket fuel. So that'll tell you there's enough energy in here to get a rocket into space. So it releases even more energy than your petrol. Another advantage is that it doesn't produce CO2, and this is the major attraction of hydrogen. This is the major attraction. So why haven't we done it yet? It sounds all good to now. Well, obviously, sorry, just before we go on to that, this is obviously a negative in the petrol column, produces CO2. This is not desirable. This is the major negative. Whereas for hydrogen, it's the polar opposite, no CO2 emitted. So it's all sounding really, really good. Why aren't we doing it? Okay, well, we have a problem. We do have a problem. It's not all good. One of the problems we have is that hydrogen is a gas at room temperature. It's a gas at room temperature. Now, gases at room temperature means that the particles flow all over the place. They flow rapidly and quickly, as we've seen. rapidly and quickly. And we can show this or represent this using a little diagram. This is hydrogen particles here. And what I'm drawing here is I am drawing motion lines to show that the particles are moving around very, very quickly with a lot of energy. This energy and movement of the particles makes it really difficult to store them. So gases are much more difficult to store. They will be able to get out of even the tiniest hole or difficult to store. They will be able to get out of the tiniest crack or hole. And they also need to be, basically, if you want to store hydrogen, what you have to do is pressurize it. So squash it into a smaller space and keep it really cold, because this will turn your hydrogen gas into a liquid, which makes it more storable. Now that obviously requires an energy input to have the pressure really high and to refrigerate it so it's cold enough to be a liquid. And it's just, if you were to put a hole in a container where there's really high pressure, then you're potentially talking about large explosions. So it's just one of the negatives so far for hydrogen is that it is difficult to store because it is a gas at room temperature. So there is the first negative for hydrogen and why we can't necessarily use it. So just a really quick recap: petrol, pros: liquid at room temperature is easy to store and it's really easy to ignite. It releases a lot of energy, but downside is CO2, and we really have to sort that problem out as a global population. We all have a responsibility to work together to try and make sure that we sort out this problem of excess of releasing our carbon emissions. We have to get it under control. So hydrogen offers a potential alternative because it's also easy to ignite and releases a hell of a lot of energy, and it doesn't have that major flow of releasing carbon dioxide. But one of the issues with it is that it's a gas at room temperature and it's really hard to store. It's not the only one though. Generally, we would find a way to make that work. If it was just a storage issue, we would probably find a way to make it work. Unfortunately, like most of the world's problems, it's not really a storage or a chemical problem. It's a money issue. Why haven't we done this? It's a money issue. Well, to understand why it's a money issue, we have to look at the ways we could go about making hydrogen. Now, there are two main methods, two ways to produce hydrogen. Okay. The first one involves taking natural gas. Now, natural gas is methane. Natural gas methane is not found in crude oil, so it's not one of the gases that we take from crude oil. The gases we take from crude oil at the top of the column are mostly actually propane and butane. Okay, propane and butane are the two gases that we collect at the top of a fractional distillation column. Methane and ethane are found in natural gas deposits. These are basically gas deposits that are found usually under oceans in like pockets. So as a separate material to crude oil. Crude oil will be a thick viscous liquid, but in other pockets underneath oceanic plates, you will usually find these pockets of what we call natural gas or methane. Okay, so natural gas or methane, and this is also used as a fuel, and we use it in our homes. So some people use methane for cooking. If you've got piped gas direct from, so if it's not a bottle outside your back door, you've got piped gas. We don't tend to have it in our area where we live in Cavan. In cities, they often have piped gas. This is a direct flow of natural gas, comes in pipes to your home. And natural gas, just like what we said before with liquid petroleum gas, is a colorless or odorless fuel. So remember the name of those chemicals that had to be added to give a smell. What was the name of those chemicals? On three, speak your answer to the screen. 1, 2, 3. Okay, I'm hoping that you said mercaptans. So MERCAPTANANS. So mercaptans are sulfur-containing compounds that are added to give a safety smell to LPG, liquid petroleum gas, and natural gas before they are sent to your home. Now, if we take natural gas, okay, and we combine it in a chemical reaction with steam, and there are certain conditions needed for this process. You need high temperatures, and you need a catalyst. You guys should know what a catalyst is from catalytic cracking and from other topics. So on 3, what is a catalyst? Speak your answer to the screen. 1, 2, 3. Okay, so you should have been saying that a catalyst is a substance which alters or changes the rate of a chemical reaction without being used up or without being chemically altered itself. So a catalyst is required here. Catalyst can be very expensive, and also we combine it with high temperatures. So I'm hoping already you're getting an idea of why this process is a problem. Okay, so that is a catalyst, and we have discussed the meaning of that key word. Well, when we do that, we can actually produce hydrogen gas. So from our methane, we're knocking off 2 of the hydrogen atoms to make some hydrogen gas, and we're also creating a product, carbon monoxide. Now, what is carbon monoxide? Well, mono means 1. So carbon dioxide, you would be much more familiar with. Carbon dioxide is carbon with 2 oxygens. Carbon monoxide is carbon with 1 oxygen. So that is the word equation for this particular reaction. And what is it called? Well, we're using steam and we're reforming natural gas into hydrogen gas. Okay, so this is actually called, the process is called steam reforming of natural gas. So this is one way in which hydrogen can be produced on a large scale. So steam reforming of natural gas is one way in which hydrogen can be produced on a commercial scale. It could be produced on a commercial scale. Now, what about if we were asked for a symbol equation? Well, natural gas is methane. So I want to speak out your answer now. You should know what the chemical formula for methane is on 3. 1, 2, 3. Okay, methane is CH4. Now, methane is a gas, so I'm going to put a little state symbol down here, a little g in brackets to show that this is a gas. We're combining it with steam, so what is the chemical formula for steam? On 3, 1, 2, 3. Okay, steam is just water. It's H2O, and its state symbol is a gas. It's H2O as a gas. And we're turning that into hydrogen, so hydrogen is just H2, hydrogen gas, plus carbon monoxide, CO. And that equation is not balanced, so what I want you to do is I want you to pause the video, and on a scrap piece of paper, I want you to balance the equation. Do that now, please. 1, 2, 3. Okay, so you should only be watching the video if you pause and try to balance this equation. Well, it's a pretty simple one. I hope that you figured out that you just have to put a 3 here. Okay, you need 6 hydrogens on the right because there are 6 hydrogens on the left. There are 4 in the methane and there are 2 in the water. Okay, so we needed to make that 6. The rest are balanced for you already. So well done if you managed to get that right. Now, again, what is the problem? Why aren't we doing this? Why aren't we making loads of hydrogen? Why don't we have hydrogen cars? Well, the big thing is because of the catalyst and the high temperatures is not economically viable. To produce enough hydrogen to power cars, we're talking about billions of vehicles, cars, motorbikes, mopeds, etc. We're talking about billions of vehicles being replaced, used on a daily basis. This is not economically viable to make hydrogen this way. You just can't charge enough for hydrogen as a fuel for cars to make it worth your while to produce it in this way. So companies won't do it. So companies won't do it unless there's money, profit to be made. They won't do it just for the good of the environment or to prevent global warming. Unfortunately, companies won't take that burden on. It's up to governments maybe to make it happen by providing some kind of a subsidy or providing some reward for a company to take on this extra task. But unfortunately, so far that hasn't happened. So why are we learning about steam reform, and why is it a thing if it's not economically viable? Well, it's not economically viable as a fuel, but we still need hydrogen gas. We still need this for a lot of things. So we still have to make it, and we would make it, hydrogen would be made by this process, steam reforming of natural gas, but not as a fuel for cars. Okay, so production of hydrogen, sure, is definitely done, and this is one of the ways it can be done. We're going to talk about, well, what are some of the ways where hydrogen has to be used? That we need hydrogen gas. We'll talk about that afterwards. I just want to tell you about the other possible way we could go about making hydrogen, and that is, and this one is potentially more um, more, it's easy to do this one because all we're going to do is take water, H2O. That's our raw product, and we've got a hell of a lot of water. Okay, so you wouldn't, you know, you're never going to run out of raw materials for this. So this would be great if you take water and you pass an electric current through it. Now, previously in your course, you would have learned about taking water, which is a compound, passing an electric current through it to split it into its elements. So what elements are in water? Tell me that now, please. What are the elements in water? 1, 2, 3. Okay, you should have said hydrogen and oxygen are the elements that are in water. And what do we call the process where we take a compound and we split it into its elements using an electric current? 1, 2, 3. I'm hoping that you said that this would be called, and this is the second way, electrolysis. Electrolysis. So that should be familiar to you, electrolysis. Now, I'm just going to move this up because I'm going to clash with what I have written down already. So this is number 2, and this is electrolysis of water. Now, if this word is new to you, where does it come from? Well, we've got electro, meaning electricity. We've got lysis, this word means to split. So electrolysis means splitting using electricity, split using electricity. So it'll work for most compounds. If you take a compound, you pass electricity through it in certain conditions, you can split it into its elements. Okay, it won't work for every element, or compound, but it'll work for quite a lot of them. So what are the elements then? What are the elements? What is this going to look like when I write the product here? On 3, can you figure it out for me? Tell me what the products are going to be. 1, 2, 3. Okay, so I'm hoping that you said the products would be hydrogen and oxygen. Those are the 2 elements. So if we were writing a word equation here, we would say water gives you hydrogen plus oxygen. It's a word equation. And the symbol equation above, hydrogen is H2, exists as a gas, plus oxygen, which is O2, exists as a gas. Okay, and then we're going to need to balance that. That's not quite balanced, right? So how would we go about balancing it? So I want you to pause the video and I want you to try on a scrap piece of paper again, balance that equation. Okay, so you'll only be watching the video again if you have balanced the equation. You should have 2H2O gives you 2H2 plus O2. 2H2O gives you 2H2 plus O2. Now, again, why aren't we doing this? Well, we don't really solve a problem when we do this. We don't solve the problem of carbon dioxide emissions because electrolysis requires electricity. Electricity has to be made, has to be produced. And unfortunately, we're still reliant on fossil fuels massively for generation of electricity. So most of our electricity still comes from the process of combusting fuel somewhere along the line. So we're not really going to solve that much of an issue in terms of saving on carbon emissions here. And the other thing is it's also very expensive. It's a very expensive method. It requires a lot of electricity. Expensive. It's very expensive. Again, this means that neither of these processes, they're not economically viable. So no company wants to do it. No company wants to make a loss. No company wants to take on the challenge just for the sake of the environment or to reduce carbon emissions. They're not going to lose money to do this. So neither of these processes are economically viable to make car fuels. Okay. Now, that's not to say we don't make any hydrogen. These processes are used. What are they used for? Well, an important thing to know is this guy here, this material, NH3. What is the name of this molecule? You should know this from your previous studies. So on 3, 1, 2, 3, what is this called? Okay, speaking it to the screen, I'm hoping that you said this chemical is called ammonia. Now this ammonia is a magical chemical because it's actually the basis of all fertilizers. And it is thanks to this discovery and the process in which we can make this, and we can make this chemical using this equation, N2 plus H2. So we'll take nitrogen gas, mix it with hydrogen gas, and we can make, in a reversible reaction, and you guys might remember that if you've studied equilibrium reactions already, we can make ammonia NH3. Okay, all three of these are gases, so that's a G, that's a G, and that's a G. And the process in which these are made is called the Haber process. And it's obviously named after a scientist called Haber, and it was his discovery of the production of ammonia that basically has led to the production of artificial fertilizers. And following this process being discovered, the world's population has grown from about 1.5 billion up to its current population, which is nearly between 7 and 8 billion. Why am I telling you this? Well, without these fertilizers, that's fertilization, I have that spelled wrong, sorry. Fertilizers is the basis of fertilizers. Without this production of ammonia and the production of these fertilizers, the world would not be able to produce enough food. It just would not be able to produce enough food to sustain this growing population that we have. So, you know, some of us wouldn't be here. It's well and good to say, oh, that would only affect somebody else, but no, it would affect, it, you know, Ireland probably wouldn't be able to sustain as many people as it does. Same for the UK, same for Europe, same for America. Doesn't matter where you are in the world, we've managed to make our land much more productive in terms of food output since these fertilizers were first discovered. The big thing though here is that when we're making ammonia, it requires hydrogen. It requires hydrogen gas, as we can see over here. It requires hydrogen gas. Now, this equation here, you will see, is not balanced at the moment. And this is actually what happens. We're going to get that's a balanced equation. So we actually need quite a lot of hydrogen here to produce these fertilizers, and that's a Haber process. Okay, so for this production of ammonia, we have to have hydrogen. So we're going to have to make it. So it is going to be made using these processes up here. So they're not economically viable to, on a large scale, replace petrol. Okay, just not economically viable. But in a case where we have to have them for something like fertilizers, they are economically viable. Companies can make fertilizers, they can make hydrogen, and then make fertilizers and still make a profit. Other reasons why we might need hydrogen are basically if we take something like oils. Now, I'm talking about oils that we eat, so food oils, okay? Food oils are what we call unsaturated fats. Now, I'm going to underline the word unsaturated, and you guys should know what that means. Okay, so what I want you to do is on 3, I want you to tell me what does the word unsaturated mean. 1, 2, 3. Okay, I'm hoping that you said unsaturated means that the molecule contains either a double or a triple bond. So oils, liquid fats basically, are liquid because they contain a double or a triple bond. So these are things like olive oil, cooking oil, vegetable oil, all of those oils that we use in cookings are unsaturated fats, and they are liquid at room temperature because of the double or the triple bonds. So we say that if we take something like, we've already seen this molecule, something like this molecule here, we have already learned that this molecule is called ethene, and we have learned that because of the double bond, it is unsaturated. But we can make them saturated. Why would we want to do this? Well, we want to do this. We want to make saturated fats, because saturating, taking these olive oil, cooking oil, etc., taking those type of oils and making them saturated, so breaking that double bond, that is going to turn them into more solidy materials. Now, I don't mean really rock hard solid like a brick. I mean like things like margarine, butter, that kind of harder oil. You can still use them for cooking. You can take margarine, put it in a baking dish and cook a cake or something. It's essentially used in the same way as olive oil, but some things require us to have a solid fat. So butter, oil, you don't really want to put cooking oil or olive oil on your bread, but you do want to put spreads like margarine, butter, whatever. So we can turn unsaturated fats or unsaturated molecules into saturated molecules by adding hydrogen, because that's what they're missing here. They're unsaturated here because they could hold more hydrogens. So if we add more hydrogens, we can make them saturated. So that would turn this molecule ethene into this molecule ethane. We've broken the double bond and we've added in 2 more hydrogens. This type of reaction, because we're adding hydrogen, this is called a hydrogenation reaction. Hydrogenation reaction. So hydrogenation of unsaturated fats is another use of hydrogen. Okay, so if we would just talk briefly and have a quick summary map, we have hydrogen. So just to summarize, we have hydrogen, and hydrogen has uses. Okay, so what I want you to do now is, from memory, without looking back in the video, I want you to write down what are the 2 uses of hydrogen. What are the 2 uses of hydrogen? So pause the video and write that down now. Okay, so you'll only be watching the video if you've written down the 2 uses of hydrogen. Okay, the first one is production of ammonia. Okay, production of ammonia, and the other one is hydrogenation of fats. Hydrogenation of fats. Okay, the next thing is I want you to tell me what are these 2 things used for. So I need some more information. Production of ammonia, where does that go then? Hydrogenation of fats, what does it do, or where is it used? Okay, so pause the video and add that in now. Okay, so I'm hoping some more detail you wrote down was something like production of ammonia in fertilizers. Okay, so used to make fertilizers. And the hydrogenation of fats, what does that do? Well, it turns oils to solids, e.g. butter, margarine. Okay, the other thing I'd like you to do from memory is I want you to write down the names of the 2 processes that we use to make hydrogen. So if you can remember the names, that'd be really good. So pause the video now without looking back and see how much of that you can remember. Just the names for now. Pause the video. Okay, so you should be playing now if you try to write down the 2 names of the processes. So the first process was steam reforming of natural gas. Now, it doesn't matter if you reverse the order, if you said that this was number 2, it doesn't matter. The second way we can produce hydrogen is in electrolysis of water. All right, the next thing I want you to do is I want you to pause the video and I want you to try from memory again to write down the word equation for each one of those, the word equation. So pause the video and try that now. Okay, so the word equation for steam reforming of natural gas. Well, the first thing you had to note is that natural gas is methane. Right, so if you couldn't remember that, you wouldn't have been able to do this. So now that I've given you that bit of help, if you weren't able to do it before, pause the video, try and finish the equation now. Okay, so you should be playing now if you have a completed equation. So it's methane plus, well, it's steam reformed, so we're mixing it with steam. Now, steam is just water. So now we can just call it steam, actually. And we're producing, what are we producing? Okay, we're producing hydrogen. That's obviously one of our products. That's what we're making. Plus carbon monoxide. That one was hard to remember, that product. If you got the rest of it, well done, but you do need to know it all. Okay, now if you can, try and write a balanced equation for that. So pause the video, try and write a balanced equation for that. Okay, so you should be playing the video if you have a balanced equation written. Right, well, methane is CH4. Steam is H2O as a gas. Methane is also a gas. And we obviously need a catalyst and heat. So we're just adding extra detail. If you didn't have this, you need to add it in. Okay, we need a catalyst and heat. Why is the catalyst? Why is that important to remember? Well, this is the reason why we can't really do it to make hydrogen to power cars, because that process is expensive, because catalysts are really expensive, and heat is hot. You obviously need energy to put energy in to get the heat. Hydrogen is H2 gas plus carbon monoxide is CO. Now that is not balanced yet. You need to put a 3 in front to get it to balance. And that is it, okay? So what about the word equation for the electrolysis of water? Let's try that one. Pause it, write the word equation first, please. Pause the video. Right, word equation is obviously starting with water. This is electrolysis. And we are producing, well, obviously we're producing hydrogen. And remember what electrolysis is. It is the splitting of water into its elements. So water is made of hydrogen plus oxygen. So that's the word equation. Right, underneath then the balanced equation, pause the video, write the balanced equation. Okay, the balanced equation is H2O is water to produce H2 plus O2. That is not balanced yet because we've created an extra water atom here in the product, an extra oxygen atom here in the product. We've got 2 oxygen atoms, here we only had 1. So that does not obey the law of conservation of mass. So we need 2 water molecules at the start so that we have 2 oxygen atoms. So 2 oxygen atoms now, but we've created another problem. We have 4 hydrogen atoms in the reactants, so we make it 4 hydrogen atoms in the products. That's the balanced equation. Well done. Right, time to do some practice questions now. Okay, so I've got some practice questions for you guys up here. And here they are. So what I want you to do is I want you to pause the video and I want you to answer those questions for me. Pause the video now, do that. Okay, right, so here are the answers. So pause the video and make any corrections that you need to for the answers. Okay, that is the video on hydrogen as a fuel, or hydrogen versus petrol. That's the end of our video. I hope you have found it useful. If you have, guys, it would help in the channel. It would help the channel if you give it a quick like there, and that would help other students who might be struggling with these topics to find the videos. Also, if you have anything else you want me to do in the Leaving Cert Chemistry course, just stick a comment down below and I'll see if I can get onto it next for you. Okay? All right. See you in the next video.